Welcome to G-Code. Today we are kicking off a series of devlogs about the Asteroid engine architecture, so subscribe this channel and press like if you haven't yet. And let's start from the header body render, where we wrote class body which will fully process motion of planets and will be responsible for its render. Firstly, we need to clear all flags of our body. For convenience we can create a union for flags type, where each variable will store state it's responsible for. Since the only values they can take are 0 and 1, we can allocate for each state only 1 bit. And by clearing flags we zero all the states. Next, while creation of the first object of type body in the whole program we need to set up all render attributes. For post-processing we will use frame buffer where we will render all body type objects. As this frame buffer will be the same for all bodies, we will make it static attribute of body class. Also, in this function we define window and WinData variables to avoid passing it as arguments to forwarding functions. In WinData we store window size and state of left mouse button. Next, in setup function we create two textures and render buffer, and of course both of them should be of window size so we can store there all pixels. Text color texture is used to store actual colorful picture of all displayed bodies. Text mask texture will be applied as an indicator of clicking some object. There we will store mask of body which is unique for each body. And by picking pixel which coincides with cursor position and getting its value we will find object it belongs to. Since we will conduct stencil test, we need a render buffer to store stencil values there. Then we attach all these created textures and buffers to our frame buffer and check whether it was successfully completed. Next we create two vectors to store vertex coordinates and its indices for vertex and element buffers respectively. And we arrive to the root function of this program, its trajectory calculation. We will follow general gravitational law. As for the first version of program we neglect interaction between planets, and that's why coefficient for acceleration won't depend on planet and can be taken away as a constant. To prediction in function we pass three vectors of type vector_q that stores position in squared coordinates. Vectors traj and dwell will store position and velocity of each processed point. But display traj vector stores position of points which we want to appear on screen when clicking planet. We will use where_left method to integrate trajectories. Firstly, we find acceleration, then we find new position and velocity. And we need to find angle change between new and previous radius vectors. For this purpose we allocate special operator. In its function we count vector and scalar products of two vectors passed to it, and with their help we find angle between these two vectors. And in display traj we will append points only when they stand on some constant distance from previously appended. Until trajectory closes we append new points to vectors, and closing of trajectory will be tracked by angle change. Now we need to set up implementation of these calculations. Each trajectory will be calculated in separate thread to avoid blocking of the main thread. And depending on time of body's launch, calculations also will be handled differently. When we launch new body after app begins its work, we will use futures. These are so-called conductors between threads which store and transmit the results of function execution. And via std async we pass lambda function which will be executed in separate thread. Exactly there we call prediction in function. In the th flags we will mark thread state. And when function in separate thread finishes its work, we extract the result in vectors and create vertex array and vertex buffer to store their trajectory points which we want to display. But notice that this function doesn't block main thread, it just asks whether function in separate thread has finished its work. But if body is created at the very beginning of the program, then we will wait until all threads which conduct calculations will finish their work. And here we won't try to omit blocking main thread because it won't make real sense. So, in these 5 minutes we covered quite a broad piece of code which I wrote a couple of days. I hope you found this video interesting for you. Subscribe G-Code to stay tuned of new videos.